Hello everybody, my name is Dan Bogos. I'm part of CGRateS core team, and I'll talk today about a new feature which we have recently introduced in CGRateS. It's kind of complementary to what we are doing. We are by default a billing engine, and we wanted to make use of all the infrastructure which we have already and extend the resource limitation. So a bit about our background. We are located in Bavaria, Germany, close to Oktoberfest, so you can understand the environment we are developing in. We got over 9 years of experience with server-side solutions in VoIP environment. This is how CGRateS came up out of our need of a real-time billing solution. We covered both wholesale as well as retail industry, and we educate ourselves to understand the real-time processing constraints and live system outages. CGRateS is a billing engine, so on purpose is not a full billing system, and we want to keep it like that. Lately we are turning into a billing suite. We are targeting to remain pluggable into existing billing infrastructures. Our customers are not always happy to get rid of their already very expensive billing infrastructure. So we need to be able to accommodate their own requirements. We stay flexible into introducing new components. So if they need to have a new VoIP switch or a new SMS service, a new data stream router or anything like that, we need to be able to support that. So these are the reasons behind why we are still only an engine. We are non-intrusive into existing setups, so we don't force people routing traffic through us or doing static routing. We share the information we provide with the telecom switch via various channel variables, and let the administrator of the switch do the decisions for their own, based on their own business logic. We have a modular architecture. It's really easy to enhance by rewriting specific components. Our software is written in Go, but via the APIs, you can do your own module out in any, almost any language which supports something like JSON APIs. We are performance-oriented. We have a pretty fancy caching system developed by us. It's a transactional one. It supports lately LRU, so the list record usage, and also we support timeouts TTL. So via this stuff, we are able to run the information pretty fast. Everything what we do is asynchronous. We support everything via micro threads, so we are not limited by system threads. That's one of the advantage of Go, for those of you knowing it. We are pretty feature rich. Multi-tenancy from day one, derived charging, this session emulation for various distributor chaining and resellers and such. We do parallel sessions, billing, everything in real time. We support account bundles, unlimited balances being part of an account with various type of records, data charging, SMS charging, minutes per destination, and all this stuff which you normally find in mobile networks. We do LCR, pretty advanced LCR, quality based LCR. We have various strategies over there. CDR stats, all this in real time, so you can know in milliseconds your ASR, ACD for your customers, suppliers, whatever. All this via flexible in-memory system again. So, as I told, we are performance-oriented. We have lately a diameter server implementation, so we support in a pretty fancy way diameter. I say pretty fancy because we are kind of standard agnostic. You can decide your diameter logic in some JSON templates. We do a number rating. It started being popular in Europe. You can charge the customer. You can attach some special tariff plans based on the region he's coming from. We have the lately introduced the resource limiter for managing resources. We have built-in high availability, and we are pretty agile in developing new features. Actually, we are pretty hungry always to hear new ideas. From day one, we were a test-driven project. We got approximately 1,400 tests part of our build environment. I kept this slide on purpose because it shows us where we were in 2013 when we first came to the first ClueCon, our first ClueCon actually. And ever since, we were adding code, which in our mentality translates into features. We are pretty conservative into adding code, so we just add it when there is no other way around. So we were increasing features ever since. In terms of performance, we provide our binary, which is able to do load tests on your own tariff plan data. So you can see here, for example, with some of our tariff plans, we got internally around 82,000 requests per second in process, and from an external program querying rating, we got like about almost 5,000 requests per second from Python. The reason for that, we can even go faster, but the JSON implementation in Go is not, the JSON serialization is not yet ideal. So, but still, it's quite some number of requests per second. You can see here some of our popular subsystems. We have almost 20 subsystems today. So these are all sort of daemons which you can run on a server or multiple servers in order to make your rating capability big. First would be, and the oldest would be what we call RAL. It contains rating, accounting, and LCR. As functionality, this subsystem will do cost for events, will also maintain accounts, these bundles, and compute LCR. And also, as part of accounting, we are able to do real-time fraud mitigation. CDR server, as concept, is a centralized CDR server, again real-time. It does also CDR replication. This is kind of nice functionality if you want to integrate it with your own network, because using this CDR replication, you can get real-time rating queues. So you push us the CDR unrated, the raw CDR, and we push it back in terms of milliseconds to the server you choose, already rated CDR. So you don't need to store anything else on CGRateS side, and you don't need to use our database. You can go with your own schema. All you need is to fire up an HTTP server, and you will be just receiving the CDRs there. And all this architecture is pretty fast because we don't use disk in this case. So you send us, we process data in memory and send it to you. So it's pretty fast. The CDR server is also able to forward the CDRs to CGRateS server, which is another separate component. Session Manager, it has a functionality to maintain and disconnect sessions. It does balance reservation, and it's also able to do, in a smart way, balance refunds. Session Manager will always stay with the switch, so in case of free switch integration, will be the component talking directly to free switch. Diameter agent, as I told, it's a diameter interface, for example, to support RFC 4006. CDR stats component, it will compute real-time CDR stats in a flexible manner. You get CDRs and they get processed in more than one queue. So with one CDR, you can update as many queues as you have configured. We have also there built-in real-time fraud mitigation. Resource limiter will have as functionality to control resource allocation. User server, it will maintain user profiles. Again, a standalone solution. It works in a way like LDAP or radius or diameter works, just that it has our own APIs on top and our own filtering capability. Aliasing is to alias parts of information for the rating. For example, an application would be to alias the IP addresses towards an account. So you don't need to have the account ID inside your switch. You just send us the IP address and we translate it via this aliasing server. PubSub service is a particular development of PubSub service of ours. It will expose internal events to subscribed external components. So if you want to get stuff like real-time balance updates in your browser, you open a WebSocket to us, and we will feed the balance updates in real time, like every, I don't know, 5-10 seconds when it happens. We feed them via this PubSub. You need just to subscribe. And this PubSub has a lot of filters. And due to that, you get quite some flexibility to open various sockets for various purposes. Free switch integration. We have more points where we can talk to free switch. First would be a real-time event monitor via ESL. We have our own, we call it FSOC library, to talk to free switch, so we are independent of, we are the maintainers of that as well. We support connection pooling, so we are able to smart receive and send events to free switch and identify the connection IDs and so on. We do reconnects and some other securities. We are using Park application for call authorization. So when the call comes, until we check balance and such, we park the call. Actually, in the dial plan, we park the call, and we transfer when we are ready to the original extension, plus setting some channel variables. So as I told you, we are non-intrusive, so you can take the decisions of your own routing still based on the channel variables which we set. We have a real-time CDR processing. We use Mode.json CDR as source. We also support there picking up extra fields, because we have what we call primary fields, some specific number of fields. You know, Mode.json CDR exposes quite some information inside. We are able to pick just the information which you want to store in your CDRs. We do also offline CDR processing for, I don't know, when there are demands, wholesale or something, which they want to do it on files. We support CSV as well as XML in a pretty flexible way via some templating. We have published integration tutorial with FreeSwitch, just that you are set up as quick as possible. Resource limiter, the subject of my talk, it's a standalone service. It can be used also outside of CGRateS scope. It manages resources. Why it was important for us to have it is because we have other systems where which we can use to make decisions. So we can tell, give me the resource, give me, I don't know, 10 channels, when the ASR allows me, or when account has enough money. So you can set various thresholds and talk to other subsystems within CGRateS. We process the events in a generic way, so you get us a hash of information and you filter it in your own way. So based on that, you are pretty flexible with the rules you have. It's a performance-driven architecture. It's fully cached, and we operate everything in memory as everything else, and we do asynchronous data backup per individual limiter object. So every object which monitors the usage is able to dump itself in the database. So you can select, I only want some stats in the database to survive over restarts or something. And we also support indexing over the hash. So if you have millions of rules, this indexing guarantees you that you will have always constant feedback, constant replies to queries. We have multiple limit usage updated with one request. So one request comes in and we are able to check like 10 different rules and allow the call if at least one rule is able to give access. We have a default negative for authorization, so if no resource is allowed, then you don't get access, or if no resource has channels available. Unlimited filters, we support and or operations there, and also data translation before input. So from string we do time rules and other stuff. We have rule lifespan, so you can decide starting first of the month I give this guy 10 channels, and next day I downgrade it to 5 channels, and in weekend he gets other stuff to some specific destination. So various rules, as I told you, generically can be achieved. We have also expiry time, so your rule is only for a limited lifespan available. We also have usage units, time to live. So you tell you have 5 channels, and if there will be no update received, then you are losing this usage. We have also integrated usage monitors, which is a particular case of fraud detection again. So you can monitor when the channels are getting full. You can perform some action like send an email that your trunk is almost full. Please prepare yourself that you will be limited. And all this stuff, it's available due to the monitor's interaction. And you can call any number of actions, and you can customize your actions. Some example of rules filters, just that you have an idea how flexible is this. So you simply define where you find your data. So in this case, is the account is one of these two, because we have an OR here. And these all are part of our tariff plan, which is in CSV format or JSON APIs. String prefix, again, it defines where is your destination in a field called destination. So as I told you, you are very generic. You can also check in a list of destinations and so on. You have also regeps available. And you can see here a rule to check and allocate resources based on the stats. So this rule will tell, for example, if allocate the resources, like 20 channels, if the stats queue with the ID CGRateS1, which is just the name of an ID, will have a minimum ASR of 34%. And or other stats ID will have a minimum ASR of 20. So if these are met, then he will get the 20 channels. And you can also get some sort of timing checks. So you can get stuff like, I want to give him 10 channels over the weekend or only over the peak time. So you can like reserve your resources to your supplier, towards your supplier. This is an example of a distributed setup which you can achieve. You can see here 2 free switches, each having their own users, even on different tenants. So they will get each one CGRateS translator or session manager, which is able to talk to various CGRateS components in the background, again in a flexible manner. And you can see here we'll talk to resource limiter for limiting the channels. We'll talk to rater to get prices and maintain account, and we'll also talk to the CDR to post CDRs. And all these services are backed up by other services, CGRateS services, and also they can be redundant via high availability setup. So I was fast enough. I made it. So questions? Yes, please. Let's see if we can get you a microphone from the background, or any chance of a microphone? Oh, comes.
Hi, my name is Eugene. I have a few questions. So the first one, you mentioned that you store CDRs on your side. Where do you store them? Is it like SQL database or NoSQL one?
Well,
and I'm sorry.
Yeah.
And the other one, what is how many CDRs per second can this infrastructure handle? Like, can it be scalable, like to 100 CDR, like 20,000 CDRs per second or more? And how is it scalable?
Okay, so on your first question, we don't really need to store it. It's an option. So if you use these rating queues, you store the CDRs yourself because we forward you the CDRs. You can use us just as a queue for rating. If we store the CDRs, you have the option between MySQL, Postgres, and Mongo. So the speed of inserting CDRs in these databases depends on how you tweak your database. It's not really something we can do more there because we already have optimized in not using joins anymore, so we have only one record for the CDR. And for example, in Mongo, I saw some basic live demo of 1 million requests per second of inserts. So it depends on how you tweak your database in the end.
Gotcha. And how many CDRs per second can you rate?
Well, as you saw, internally about 80,000 requests per second, and if they come from outside, we estimated about 5,000 requests per second. So it depends. I would say 1,000 for sure.
But what if we have like 20,000 CDRs per second? How can we
then
scale it?
You need to simply use different CDR servers because you can use as many as you want. You can keep a database in the background, and you can put as many CDR servers as you want. That's the beauty of it. You can do microservices, or you can do various hardware servers. Yes, a question there.
Raise your hand.
One second.
Here we go. Hold it close, please. How customizable is the CDR format? Is it totally generic?
Yeah, it is. We store the CDRs internally into an object, but you can import it into our object via some JSON templates. So you can pick which fields from where you want. And we also, as I told you, we have our primary CDR fields, and in extra is a hash map, so you can put any fields you want.
Okay, so it could be arbitrarily complex in terms of like retries and that kind of thing.
Yes, and also we support CDR forking. So for one input CDR, you can get 100 rated because we fork the CDR based on your rules. So, and we can also pick for every run different fields from your input.
One last question.
Yes,
Is there total flexibility in terms of selection of database?
Well, we have an interface for that, so we can always write it. But for now, it's very hard for us to support that many databases. But it's just writing, I think there are less than 30 methods to support it. So it's writing an object with 30 methods, and you get a new driver. You're welcome.
Any other questions? Oh, coming up.
So I just started digging into this last night, so I'm very new at this.
Yes.
We were playing around. We got a kind of a unique use case. We need to load approximately 3 million accounts into it. And from what I understand, you only support Redis and Mongo for that. We ended up completely crashing the server when we tried to do that. Do you have any suggestions for handling that many accounts? Not CDRs, but the accounts themselves?
Yeah, well, I would suggest a Mongo cluster for that. This is why we came up with Mongo, was because Redis was very good for us, very fast, but it was not that easy to cluster it and make it bigger. So we said for smaller installation, Redis is ideal, and for big enterprise installations, we'll go with Mongo. This is why we also have replaced kind of in our plans MySQL and Postgres, so we go with only one database, Mongo, which does for us. So I would suggest you a Mongo cluster.
Any other questions?
Big round of applause for Dan.
Thank you very much. Thank you.